Okay, so for the lower frames, I'm gonna go ahead and apply my decals to them now, because I find that with the lowers it's easier to do when it's not on, when they're not on the helicopter. However, you know, you could feel free to leave them off. You can do whatever you want. You can actually refer to the diagram in the manual, and that'll actually help you figure out where to place the decals so that it looks as it's supposed to. Okay, so here's a word of caution. These decals are incredibly sticky. Once you put them on, there's no getting them off. I mean, you can get them off, but they are very, very, very sticky. So fair warning, just make sure that, you know, as you're putting these on, you get them where you want them to be. Otherwise, you'll, you know, be having to deal with your decals in locations that you may not necessarily want them, or maybe they might be skewed. But just keep that in mind as you go and apply these. One thing that I do like to do when applying decals like these, take yourself a pair of scissors and actually cut out the decals that you want. It just makes it easier over time as you go to apply these, because otherwise they're transfers. So as you put them on, you'll need to peel off the top layer, and I'll show you how these get applied. Okay, so once you find the decals that you want, go ahead and trim them here as well. And the idea is you want to have the line be cohesive from the bottom all the way up the frame, then back onto the rear side of the frame. So I find that it's easier with decals like these to start on one side, and then you don't necessarily want to peel the backing off entirely. So as you work with them, you need to figure out how to separate your top and bottom layer like this. Once you get that started, kind of peel it back. You can expose parts of it, but like, you don't necessarily need to do it all in one go. Now, in my case, then work your way from one side to the other to try to squeeze any air bubbles out. All right, so that's that first decal. Go ahead and leave that for now with the transfer tape. I'm gonna come back here and I'm gonna finish out installing the second decal. So the idea is you want the lines to be parallel as best you can. So the idea is you kind of want these to be as parallel as possible, while also conforming to the frame dimensions. That looks pretty good to me. So I'm gonna go ahead and tweeze that back. And we can see that my line is drawn on the rear of my lower, or on the left side of my lower. Go ahead and push them down a little bit more. Now these are transfers, so you can go ahead and take the top or the transfer layer, peel it back at as sharp of an angle as you can do, like this, and it'll leave the sticker in place. Do the same thing for the top one. And those are your stickers. You want to do this on both of the lowers. Jonas's signature goes here. The manual will tell you exactly how to orient it if you really want to orient it, but honestly, you just stick it onto the side and it looks pretty good. And then finally, for my lower on the left, you want to find the 3D Performance decal that matches the contours of your frame. And so the rounded side of it is going to be towards the top, and that's the one that you're going to want to use. These ones you don't need to cut off because they're just a sticker. And go ahead and peel that off. Line it up on the frame, like so. These ones are not as tacky, so you can kind of get away with repositioning them if you need to. And there we go. That's 3D Performance on the back. I'm gonna go ahead and do the same thing to the other side. Okay, so for mating the lower frames to the uppers, we're using a couple of different bolt lengths. On the right side, we're gonna be using the M3x32 bolts. On the left side for the rear, we're going to be using the M3x20s. And the reason we're using the M3x32s is because if you remember when we assembled this, we needed to make sure that the slot on the tail clamps, tail boom clamps, were actually facing the right side of the helicopter. So these are going to be what you use to tighten down your tail boom. Now, we're going to go ahead and, so to walk you through where these various screws are going to go, the M3x32s are going to be the two on the rear. You have a M3x18, and this is going to be to actually, this is going to end up going through this hole where when we mount our auxiliary plate into place, our upper auxiliary plate into place, that's going to be what this threads into. And then we have an M3x26, and this M3x26 is special because we're actually going to put a spacer on it, and then eventually a rubber nub here, and this is going to help keep the canopy off of the frame components on the front. So to go ahead and start off with, I'm going to go ahead and add a little bit of Loctite to my M3x32s. Position that, and stick that through one of the back two holes. I'm going to use a 2.5mm driver with these. And you don't really want to clamp these down just yet because we still need to tension our tail belt correctly. And I'll walk you through how to do that in a little bit. Same thing for this one. Just leave that loose for now. Okay, now moving on to the front, we can go ahead and grab our auxiliary plate. So our upper auxiliary plate. Now, the auxiliary plates cross braces are going to be on the top side of the plate. So these aluminum pieces are going to be on the top. So we can go ahead and slot that in. If you look, I can slot that into here between the uppers, and it'll go in like so. So once that's there, we can go ahead and grab our M3x18, put a little bit of Loctite on this, and send it through our frame and try to find our auxiliary plate on the other side. And there we have it. Now we're threading that in. Now I'm not going to tighten that one either because I like to wait until the very end to tighten everything down. Now this is our M3x26. Put a little bit of Loctite on this one. And do the same thing where we send it in. Make sure you have your spacer on it. You want to seek out that the upper auxiliary plate. So you might need to move it around a little bit to help it find the threads. All right, and that is that. So now we can go ahead and torque these two. And that is going to be what we need to do primarily to mount the lower to the upper. Now we can go ahead and grab one of our battery latches, and you can see how there is a perfect spot in the frame for this to slot through. There's also threads in here as well, and you'll grab the smaller of the screws. I believe these are M2.5s, and you'll want to put a little bit of Loctite on them and then send them in, and you'll use a 1.5mm driver for these. Alright, tighten them evenly. And there's our battery latch. We can see now that the battery latch is a lot more secure now that it's being guided through the frame there. We can take our little rubber cap and put that over our spacer and bolt combination on the front of the frame. And now we can actually mount our rear auxiliary plate. Now, the orientation of whether this faces forwards or backwards is kind of up to you depending on what your intentions or plans are. So in revision 1 of the manual, we actually flipped this plate, and the reason is so that you have a little bit more space between the tail servo and the plate here, but you can do it the other way as well if you do decide that you want to leave it in. Now, you'll use the smaller M3x6 screws with a 2.5mm driver, put a little bit of Loctite on them, and go ahead and just mount up this plate. In my case, I'm going to face it so that the braces are facing rearwards so that I can try to fit a capacitor pack within there. And tighten those down evenly. And there we have it. Our lower for the right is now attached. And we'll move on to the left. And there we go. Our lowers are now installed. It's starting to look like a helicopter airframe now. Okay, so now is time to, it's actually time to try to tension our tail belt. And so we have this really cool micro adjustment tail belt tensioner here, but you still need to do a major tail belt tensioning, which is what we're going to do right now. First off, you want to make sure that your two M3x32 screws are loosened, and the reason is because you don't want any clamping force on your tail boom. You can go ahead and see that you have the ability to slide your tail boom in and out, which is good. Now, your tensioner here, you want to go ahead and turn this counterclockwise all the way out. You want this the stud to be sticking out as far as possible. Now, within reason, you don't want to break it or anything like that, but you do want to make sure that that's sticking fully out, and so there is no tension being put onto the belt by the pulley here. Now, you go ahead and pull your tail boom out to the point where there's no slack in the belt. You don't want to be pulling on this thing like it's going to be like how you would normally tension a helicopter, because that's what this is supposed to do, is to add that tension back on. Now, once you do that, you can go ahead and tighten down your M3x32s. Now, I like to start on the front, and the reason is because I have that, the tail clamp has that nub on the front there. So as I go through here, I'm going to tighten that, the front one. I'm now going to tighten the rear one. All right, so now that I've tightened these two M3x32s, I can go ahead and actually screw and turn this back clockwise until the stud that's sticking out of it is flush with the knob. And when you do that, you will end up with a tail belt that is perfectly tensioned for this helicopter, and that's how you tension your tail belt. Okay, so we're gonna start working on our third bearing block as well as our tail servo supports, or our tail servo mount. The components that are included here are going to be they're going to be described in the manual, but like always, I like to go ahead and green Loctite my bearing into my third bearing block. So I'm going to go ahead and clean off this bearing with alcohol, green Loctite it into place, and then I'll show you how I sort of set up my tail servo, because you kind of want to make sure that you set your tail servo up outside of the frame. I mean, you can do it within the frame, but I find it's a little bit less frustrating to do it outside, and that way it just makes things a lot easier. All right, and now I have my third bearing glued into my third bearing block. Okay, so for the tail servos, what's going to happen is we have some more of these 4mm nuts. Now, if your tail servo has a 5mm holes, you can go ahead and dig out the 5mm nuts for them, the alignment nuts. But these nuts are going to go in from the top here, and then the servo, these plates are going to mount here on the bottom of the servo. And so when this entire assembly is in the frame, it can actually be quite difficult to get to fish these nuts into place. So I find it's a little bit easier to go ahead and start tightening things down outside of the frame before we stick this entire assembly in. So I'm going to go ahead and take my nut here. Now we're going to be using the longer of the M2.5 screws, and those actually stick through the block here. So I can use a little bit of blue Loctite with a 2mm driver. and get these things started. Now, I'm not going to tighten them just yet because I can tighten them once they're in the frame. So this is just so that you don't have to fish the nuts back through the frame when you're setting everything up. Now, like I said, I like to leave these a little bit loose now so that when I go to fit this assembly into the frame, things can kind of move around and hopefully slide into place. So leave them a little bit loose, and then you'll torque them down once you actually get the tail servo mounted into the frame. So the arm for your tail servo is going to face, if the helicopter's facing forward, it's going to be facing to the left. So the splines for your servo, or your output shaft for the servo, is going to be on the right. And what I'm going to do is I'm going to go ahead and grab the helicopter. It's going to be a little bit hard to kind of show how this goes in, but I'm going to do my best, at least from the bottom, to show you how this entire thing, or the tail servo, fits in. And then we'll also have to mount our third bearing block into place. So now my tail servo is actually mounted into my frame. I can go ahead and grab my 2mm driver once again, use some Loctite, and get the blocks tightened down. Okay, and then we'll come back and I'll tighten down my tail servo mounting screws. Now, the third bearing block goes into this spot right here. It slides right in. You want to make sure that the bearing, the more open side of the bearing, is actually facing upwards, and that's because if the shaft is going to be pushing down on it. If it's mounted incorrectly, then your bearing, if you don't glue it, then it can actually fall out, and it's not really doing anything. So make sure that your bearing block is oriented correctly, where the lip of the actual bearing block is what's facing the bottom of the helicopter, and go ahead and slide this in. All right, so there we go. Our third bearing block is now mounted into place. We can use our M3 screws with our 2.5mm hex driver and get this tightened down. Now, I am still not gonna fully tighten them until all four are in, and then I'm gonna go in a cross pattern as I tighten them to make sure that there's an even amount of torque. And there we go. Now we have our third bearing block and our tail servo both mounted into the helicopter. Okay, so for the landing gear, it's pretty easy to get these together. You will need to glue the end caps, or the caps for your landing gear in. The manual says to use AB glue, which is epoxy. However, I've found that CA, or cyanoacrylate, tends to work just fine for something like this. So that's what I'm going to use, and I'm going to get the landing gear roughly set up, and then we'll be back. All right, so there's kind of a rough setup of how the landing gear is going to be oriented. It comes with these set screws. I'm not going to put these set screws in just yet because I don't know the exact distance between the two landing gear supports I need to have, but so I'm going to go ahead and actually just start getting this installed into the helicopter, so you can actually place the frame over the landing gear, align them, and then use your M3 screws over here with a 2.5mm hex driver and a little bit of Loctite, because these are going into brass inserts, and get everything tight, and that'll be your landing gear. All right, and so now my landing gear is mounted into my frame. What I can actually do now is, what you can do now is find your set screws and drive them into the landing gear. Now you want to just make sure that you get these aligned however you want, and that, you know, they look proportional to however you want to do them. I tend to hang my helicopters up by their skids, so I tend to try to leave a little bit more material back here, but you can do whatever you want. Alrighty, and there we have it. The landing gear is now installed and it is starting to look like a helicopter. Alright, so I'm going to go ahead and install the motor mount. Now, I don't have my motor yet, so you probably will have a motor already on the motor mount, but because I don't have a motor yet, I'm still going to show you kind of the screws that need to be used and how to tension, or how to do your belt tensioning. So this assembly will actually fit between your upper frames here. You slot it down. And if you remember, we actually had those two nylocks that we put into the frame up here. And those are going to be what you drive the M3x10s into. So you're going to grab a 2.5 millimeter driver. You can go ahead and start to thread them down. You kind of have to find them and make sure that they were aligned with your frame or with the bolts. You can start to tighten them. You don't need to tighten them fully. That's going to not be until we set the actual tension, or the when we set the backlash. But using your M3x10s, make sure that you get them into the nuts. Go ahead and start to tighten them. Now, all of the side screws, which are going to be M3s as well, are going to need the washers put onto them, and you're going to have 4 M3x12s and 2 M3x8s. The M3x8s go into the bottom, and so you can see here that this shorter screw will go into the bottom because there's no lower servo mount in place. And I can go ahead and put those in. I'm not going to tighten them, and I'm also not putting Loctite on them because I have to pull this assembly out to get my motor in. But if you are going to be setting your helicopter up for first flight, go ahead and Loctite these screws now. All right, so the tail fin is the next step here. If you want to, you can go ahead and put the stickers on your tail fin. I am not going to do this. I have done it on my helicopters in the past. My trick there is basically just try to get them as lined up as you can. But for this specific helicopter and its color scheme that I'm kind of envisioning, I'm actually going to leave the tail fin there. So that's why it doesn't have any stickers on it. You're going to have these little button head screws that you use a 2 millimeter hex driver with. You want to put a little bit of Loctite on the screws, and go ahead and just line up your tail fin and get everything lined up. Put your first screw in. You can kind of see how it actually indexes in with the button head screws that were there for your tail belt tensioner. And here's our second one. Tighten that up. And now you can go ahead and torque them. And that is installing the tail fin. Okay, so the tail push rod is already pre-cut. It's going to come out of the box ready to go. The newer versions of the kit are going to have a version of these tail push rod ends that have a clamping mechanism. Mine don't have that, so I'm going to have to still use an epoxy. I like using JB Weld for tail push rods, and you kind of need to coat it and stick it in. Then you'll put your links on, your ball links here, and that'll be how you set this up. Now, the manual specifies that end to end, from link to link, at the end of the link to the end of the link, you want the tail push rod to be 818.5 millimeters long. So just make sure that you that's the case, and once you do that, you will be good to go. Now, one thing that is kind of nice to do if you want to have a little bit cleaner of a tail push rod. So you can see here that as I push this entirely in, I can go ahead and pull it out, compare it, and see, oh yeah, it actually does go all the way into my end here. You can actually take a piece of painter's tape, and when you stick this into here, use a piece of painter's tape, stick it around here, and that way when you apply the epoxy to your tail push rod and you push it onto the you push your tail push rod end on, you can guarantee that you're pushing it all the way on, but also it'll help keep your tail push rod a little bit cleaner down the line. The other thing is going to be you can clean the end of your tail push rods with alcohol, and that helps so that the epoxy does stick a little bit better. The final thing would be you can actually sand the tail push rods down a little bit so that the epoxy adheres a little bit better as well. If you're going to do that, make sure you do it in a well ventilated area. Carbon fiber dust is no joke. You don't want to breathe that stuff in, but you can do it in a well ventilated area, just a little bit, just rough up the surface just a little bit before you apply your epoxy to it, and you should have some pretty good results. All right, so I got my tail push rod glued up here. I used JB Weld, mixed it. It's a 2-part. Went ahead and used alcohol to clean off the carbon rod as well as inside of my tail push rod end. Applied the JB Weld, went ahead and sat it on. I used my painter's tape method, where you basically wrap painter's tape around the carbon push rod when it's dry, when you have your tail push rod end on, so that you can both try to keep it clean as well as try to or ensure that you push that tail push rod end all the way on. The manual specifies that the end-to-end of this tail push rod, so the end of the ball links or the entire rod, should be 818.5 millimeters. If you're in the US and you have a tape measure that does not have metric on it, that about roughly converts to about 32 and 2.22 inches. And that's slightly under 32 and a quarter, slightly over 32 and 3/16. It's actually basically if you have a tape measure that has enough granularity to do 7/16, you can do 32 and 7/16, and that should get you pretty darn close to what 818.5 millimeters is. This is, kind of important that you get that right, because when you go to do your setup, you want to make sure that you have your full travel for the tail servo based on the fact that it was centered over the body of the tail servo. Now, when I go into actually setting up my helicopter, you still set up your endpoints and things like that, so it can be less important. And also, depending on the actual flight controller you're using, if you're setting your center points, you can kind of get away with having the rod not exactly accurate to what it was specified at. But you should always, make sure that you set things up as precisely as you can, because it'll generally make your flying a little bit better. I would say that you just want to make sure that you set your tail rod or your push rod up to 818.5 millimeters. And once you have that done, the manual will show you your 2 tail push rod clamps. You'll note that in the bag that the tail push rod came in with these clamps, the hardware isn't here, and that's because it's in the next bag that I'm going to go ahead and move on to now. Okay, so in bag number 24, the only things that are in there are going to be your M2x8 screws, which you can see here, or technically I guess they're bolts because they're going into nuts, as well as the little M2 nylocks, and these are really, really small. You'll note that they're really, really small. So just keep that in mind. If you have a nice set of small pliers, you can use those to try to help when you guide these in. But yeah, we can go ahead and start mounting the tail push rod to the helicopter. Okay. So I'm going to do my best to try to show this. I've gotten to the point of the build where the helicopter is a little bit bigger than my desk, and normally I've got my tail boom sticking off to one side or the other. But in this case, because I want to show you kind of how the tail push rod goes on, we can go ahead and do this. One thing to note, when you're assembling your tail push rod and setting up your links are going to be set up opposite of each other in terms of orientation. So the OMP Hobby on one end is actually going to be opposite. So if I come over here to the other end, you can see that there is no OMP Hobby, or maybe, that's because the balls are pointing towards each other in the actual helicopter with your servo in place. So just make sure that when you're setting your 818.5 millimeters for your tail pushrod length, you go ahead and correctly orient your tail pushrod link. So these plastic tail pushrod guides are quite easy to snap over. You can see that just snaps onto the tail boom. You can go ahead and do it for both. The tail pushrod itself, you can actually go ahead at this point and attach it to your servo. You want to make sure, as if you're going to do this, that your tail servo is properly set up in your flight controller before you power your servo, just in case, for example, you have some, weird endpoints or something going on with your flight controller. But you want to go ahead and make sure that the center of your servo is going to be, 760 microseconds, or 1520 or 1500 if you're going to be running a wideband. So go ahead and you can actually go make sure that your ball links are correctly oriented. So the side that says OMP Hobby is actually going to face away from the ball, and then you can actually look at the ball links themselves, and you'll see that one side is actually going to have a bigger hole. Okay. So I've gone ahead and got my tail push rod attached to my tail boom. One thing you can do is actually center your tail servo and check to see where you're at here on the tail. And I'll go ahead and move it into the camera. You want to make sure that you have a 90-degree angle between your tail bell crank base and the tail bell crank, and that's going to be how you know you've got everything mechanically set up to specification. And that's going to be with a tail push rod that's 818.5 millimeters long. So now the manual will specify a length for your tail push rod that is based on the end of the boom, and we're looking at 263 millimeters between segments from the rear. And that, if you don't have a metric tape measure because you're in the US or something like that, that actually converts to about 10.35 inches. So that's going to be a little less than 10 3/8 of an inch. Now, it's important to note that the measurements for 263 millimeters are slightly different, because what's going to happen is you're going to measure from the end of your tail boom to the center of your rear tail pushrod guide, and then from the center of your rear tail pushrod guide to the front end of your front tail pushrod guide. And so your measurements are not going to be exact. They're going to be slightly off. It's not going to be exactly 263 from center to center, but that's actually on purpose to try to help with resonance and things like that. So what you can do is go ahead and grab your M2x8. Now, because these are nylox, you don't need to put any Loctite on them. You can put your nut on the back of your tail pushrod guide and go ahead and thread this through and start threading it down. Now, you don't really want to crank it down until you know that your measurements are right. So what I like to do is go ahead and get everything started, measure them out, place them where I want them to be, and then go and tighten them down. Okay, so one thing to note as you go to tighten down your tail pushrod guides is that you can over tighten these. You don't want it to be squeezing down on this rod to the point where it will not allow it to slide back and forth, because that stiction could potentially cause you some tail setup issues down the road. So just be mindful as you go through and tighten these down. Part of the reason I left off my stickers earlier was actually for the tail boom was because you can actually see that the stickers will actually more or less fit over or fit between the tail pushrod guide when you have this properly set up. So that's kind of nice that you're not necessarily obscuring the logo of the name of the helicopter or anything like that. And that was kind of my goal here, is to make sure that I didn't have a tail pushrod guide over anything that I didn't want to obscure. And there we have it, the OMP Hobby logo mounted onto my tail boom. And you can see how it fits between the two tail pushrod guides when you set them And that's a good indicator to how you do that. I find that that's a little bit easier as well when the tail boom's mounted in the helicopter, to actually kind of get the perspective necessary to set this straight. But you know, your mileage may vary depending on however you decide to set this up. Alrighty, so the next step in the manual is actually going to be to go ahead and put your swash plate on with the links, the ball links for the helicopter. I am actually going to skip putting the links on because I am not done with my electrical wiring, and I find that with the links on, it makes things a little bit more difficult. However, I will put my swash plate on and show you the process of mounting the head and everything up together, and even I'll put the pitch links on between the swash plate and the head. So we'll go ahead and grab your swash plate that you already Loctited all the balls onto, and slide that onto your main shaft, and it'll be nice and almost it's satisfactory to put this onto here. Now you'll note that I did actually change my servo arms from the plastic ones to the metal ones. I decided that I wasn't too happy with how close the nylock was actually getting to the servo housings, so I went ahead and just moved over to the metal ones. Like I said, the manual does say that you can use the 4.6 millimeter long ball screws, but in my case, my kit didn't include them, so I just went ahead and used the longer ones with the nylocks. Honestly, it's probably more secure that way anyway because it's a jam nut, but I also did do Loctite on the threads of the ball itself when I put them in. So now we have our swash plate on. The next step here in the manual is actually going to be to install the swash plate guide, and that's going to be going on the back here. Okay, so now we can go ahead and install our swash plate guide. This is a nice solid piece. You'll see that it actually has recesses for the socket head cap screw on one side, and it's flat on the other. In my case, I don't really like to get Loctite in or have Loctite touch plastic pieces. I've found that it can lead to them becoming brittle. However, I haven't actually run into that with the M7 kits when Loctite does get in contact with the plastics, but still I like to be safe. So what I'm going to go ahead and do is take my the M3x12s, stick them through, and I'll apply Loctite to the screws after they've already been stuck through here. So I'll go ahead and take my Loctite and apply my Loctite to my screws. Once that's done, you can go ahead and use a M2.5 driver, or once that's done, you can go ahead and use a 2.5 millimeter hex driver. You can see how that will just slot over the guide screw on the swash plate, and you can find the threads in the top bearing block. And go ahead and, in my case, because I applied Loctite to both of the screws, I'm going to go ahead and evenly tighten it down. And you don't need to really muscle these down. I mean, if you put a good amount of Loctite on them, you'll be fine. It is plastic, and there's nothing to really prevent you from completely squeezing the socket cap screws through it. So just keep that in mind. You don't really want to muscle that down too crazy. All right, so we're getting really close to finishing this airframe. The next step in the manual is going to have you put the rotor head onto your helicopter. Now, it makes the mention about the longer washout link screws that go through the head here and clamp the head onto the helicopter. Now, I actually recommend before you start clamping these down, you actually go to the next page, find the bolt that goes through the head block and through your main shaft, and use that as a guide. And because otherwise, if you go and start clamping down your washout links, you probably won't be able to move the head around, and that is not going to be ideal. So what I'm going to do is go ahead and dig those out of my my bag, and I'll be right back. Okay, so I'm back now. In bag 27 is going to be your M4x23 socket head cap screw or bolt, as well as the M4 nylock that corresponds to it. I'm not going to put the nylock on just yet, or rather, I'm going to put it on, but I'm actually going to loosely tighten it, and that's just because I want to go ahead and actually tighten my washout links down in an even pattern, but I don't want any tension on the head block itself when I'm going through and tightening that. I'm just using this to guide the head and make sure that everything is lined up. Now, if you look at the head, you'll actually see that there is a round cutout and a rectangular cutout. And so the rectangular cutout is going to be what you use for your nylock, and that's going to retain the nylock, makes it easy because then you can just use your 3mm hex driver to go ahead and tighten down the bolt here when you go to tighten it. Now, you want to make sure that your washout links are on the correct side of your head when you go and place this down. And now that that's down, I can go ahead and take my M4x23, slot that through, and on the back side of it, I'm going to go ahead and start to thread it on. Now, like I said, I'm not gonna, I want this to be loose. I don't want there to be any tension on this bolt, but I do want to have this here so that I don't lose it. Makes things a little bit easier. Now, you're gonna take a 2.5mm hex driver. Remember that we did not put any Loctite into the head block here. So now is the time that you can go ahead and pull out the washout link. Keep in mind that there is that spacer that you put onto the head block. So you want to make sure that that stays in place. But I'm going to go ahead and pull my washout link out. I'm going to apply a little bit of Loctite to this and stick it back in. I'm going to do that on both sides. Now, I'm not going to tighten them down when I go to put them back in, because you want to evenly tighten them. You want to make sure that you go back and forth and tighten them and do it evenly, because otherwise the head could not, maybe not necessarily be on, or it'll be misaligned, and you really don't want that, because then you'll be running into problems. So there we go. Loctite on the first screw. Go ahead and get that close. I'm gonna flip my head around and pull this one out with my 2.5mm hex driver. You see that spacer is trying to stick on the head there. Pull that out, put my Loctite on my screw, stick that back through, and now I can start to tighten this down. And what I'm gonna do is I'm gonna do the same thing that I did on the other side, which is basically do it until I feel a little bit of tension. And there we go. So now, what I'm gonna do is I'm gonna go ahead and tighten these down evenly. And notice that they're not connected to my Swashplate just yet. The reason for that is because I want to be able to feel them. I want to know if there's something that's going wrong as I tighten these down, because what can happen is if something's not right, you don't want your washout arms to be, you don't want them to be uneven in terms of the pressure that they require to move, because that can lead to weird head dynamics in my experience. So as I'm going back and forth, I'm just tightening them down. Now, remember, these are clamping, so you're not gonna like sit here and put like 100 foot-pounds of torque on this or anything like that. You just want to make sure that they clamp onto the head so that the head block is evenly on there, as well as the fact that you want enough tension so that these bolts will not back out, because if these screws back out on you, then you potentially lead to bad things. Now that I have those two tightened down, you can see that they're flush with the head on the back here, and you don't really want them to be sticking out, because if they're sticking out, that's not right. They could make contact with your washout arm. I'm actually going to go ahead and grab my 3mm hex driver here and finalize tightening down this the major bolt through the head. So I'm going to go ahead and just tighten that down, and there we go. So now we have our head assembly with the blade grips and blade grip arms and everything mounted to the helicopter, and you can see that the washout arms are free. If you are spinning your head around, just make sure that you try to move these out of the way so that they don't make any contact with anything like the Swashplate and potentially get damaged. But otherwise, that is it for that step. Okay, the last step that the manual is going to have you do on this page is going to be to attach the washout links to the Swashplate, as well as the actual pitch links that go from the Swashplate upwards. Now, you'll note on your Swashplate that it is it is symmetrical from side to side. However, not all four sides are the same. So the ones that match up with your washout links here are going to be the ones sticking out, like directly out perpendicular from the main shaft, and then the ones that are at an angle or basically like 90 degrees to the swash plate, or perpendicular to the ones that are sticking out and have the arms for them on the swash plate. The upper swash plate are going to be the ones that you use for your pitch links. So I'm going to go ahead and get my washout links pushed on now. Now keep in mind that these are super tight from the... Keep in mind that these are going to be super tight from the factory. I mean, we're talking 6mm links. These are the biggest in the industry. Unbelievable for the amount of power that, or they're really good links, 6mm, but they are going to take quite a lot of force to get on initially the first few times, but they are going to be very secure. So just keep that in mind as you go through pushing these on. You can use your thumb. I mean, it takes a lot of force to get it on like that, but you can use your thumbs for these ones. Okay, so there are my washout links. Now they are attached to my swash plate. I can still move my swash plate up and down and everything is nice and smooth. And then I'm gonna go ahead and grab my pitch links, the two small ones. And remember, when we put these together, they have an up on them. And so you'll wanna make sure that the up indication on them is facing upwards for the helicopter. So you can go ahead and do that. Now, you wanted to make sure that the OMP Hobby logo is on the same side for both of the on both sides of the pitch link. So just make sure that that's the case here, and you can go ahead and snap these on. All right, so these are going to be very tight. If you're not really comfortable with how tight they are, and they will break in, by the way, but if you're not exactly comfortable with that, if you have like a nice pair of parallel pliers like the Knipex ones, you can actually very gently squeeze the ball link, and on the outside here, very gently squeeze it. And what that will do is open it up and make them looser. And so that actually just made this significantly looser. You can do it while they're still on the helicopter, but you know, they will break in, and actually the more you mess with this, the more you'll feel that as it breaks in, and you know, after the first few flights you'll see that. But that is something you can do if you find that the links are like uncomfortably tight for you. And I'm going to go ahead and get the pitch link here attached to my blade grip arm. Okay, and there we go. Now that my pitch link here is on, we notice that the OMP Hobby logo is facing away from the ball, the stem of the ball, and that's just because the, you know, honestly, I don't think you could get them on the other way without like using tools, like major tools. So there is that, but just you want to make sure that you make sure that the OMP Hobby logo is facing away from the ball. And I'll do the same thing on the other side. Alrighty. And there we go. Now the head is assembled. I've got my pitch links installed. The next step in the manual is going to be going and doing our blades. I can walk you through the hardware that was included in bag 28. So you've got your blade shims. Now these are really neat. You also have these little collars that work with them, and I'll show you when I go to install the blades how I use them. You'll also have the corresponding nylocks. You have an M3 nylock, and these are going to be for your tail blades, as well as an M5 nylock. Now these are neat. These are actually CNC nylocks, but you'll have both of these, as well as the corresponding M3 and M5 bolts for your blades. And we can go ahead. I'll actually walk you through how to install the blades. Now, these spacers that you use depend on the blade root. So the idea is you shouldn't need to use the blade spacers that come with most blades if you know, you have two options here. Now the thinner ones are going to be used for the Rotortech blades that I'm running. I'm going to run Rotortech 700s on this helicopter, Rotortech 700 Ultimates. So I'm going to go ahead and use these, but if you have blades with a thinner root, you can actually go into the bag for I think it's the page 32 bag, and grab out the thicker shims and use those. And the manual does detail what's going on here. So I have here my Rotortech 700 blade. I'm going to go ahead and you can see that, you know, without the shims in place, it's like going to be loose. So we got to go ahead and install our shims first. So I'm going to go ahead and take my first blade shim here. I can put it into place. Now you'll want to grab one of the collars. I like to use something like, you know, a driver or something to help guide the collar in, because they are retained when you stick them in, it's just they have to be pushed up enough, and if you don't have a you know, you can't really get enough pressure on that. So go ahead and start to place that in, and you can get your collar into place, and these are actually going to be retained, which is really, really nice. Now take your you can take your second blade spacer, grab another collar, and from the outside again, and this time coming from the top, you can actually stick them in to place. So go ahead and put that there, and then for me, I'm just going to go ahead and hold my spacer, and that clicks into place. Great. So now I can take my blade and actually put that in. The blade bolts here, which are the M5 by 32, I believe they are going to go ahead and come in from the top like a conventional, you know, helicopter. And you'll see there that my spacer just fell out because it wasn't fully in. But once you get this tightened down the first time, it'll actually they'll actually stay in place, and you won't need to mess with them anymore. So you can go ahead and take your M5 nylock, and you can help find the there's you know, the hexagonal groove in the bottom of your blade grip, and that'll work. You'll need to use a 3mm or a 4mm hex driver for your blade bolts because they're M5s. So I'm gonna go ahead and grab an M5 or a 4mm hex driver. I'll be right back. Okay, so I've gone ahead and grabbed my 4mm hex driver, and now as I go to tighten this, it's going to be tight the first time you do this, and then you're going to tighten them down, but then you'll find that the spacers don't move around with your blade, and that is good to go. Now I'm going to go ahead and do it on the other side, and I'll come back once the blades are installed. And there we have it, both of my Rotor blades now installed on my helicopter. Now we can go ahead and move on to the Rotor tail blades. In my case, I'm going to be running the 106s, and I'll walk you through how those go into the tail. I'm kind of out of space again, so I'm going to go ahead and just show you for how these these Rotor tail blades get installed. Our M3 bolt is going to go, and you can stick your blade in like so, stick your tail or stick the bolt through, and grab your nylock using a 2.5mm hex driver. You can actually go ahead and tighten down the tail blade. Now you want to make sure that you get your tail blades oriented in the correct direction. In this case, facing the tail rotor assembly, the tail blades spin counterclockwise, so that's going to be why the leading edge of my tail blade is facing to the left here. And then you can go ahead and do the same thing with the other one, making sure that your orientation for the tail blades is correct. And that's it. Now we have concluded setting up our helicopter, and we've mounted our blades to it. We've mounted our tail blades to it as well. And the next step here, in the manual, you have a few more pages. It walks you through how to mount your ESC into place, gives you some of the hardware that you would use for that. In my case, I'm going to be running a Sunny Sky 300 amp ESC, but I'm going to show the I'll show the setup process for that in a different video, as well as how I sort of mounted everything up, because I still have to do wiring, and I am going to be running a V-bar Evo on this helicopter, so I haven't done the wiring, and that's not really part of the build here. So that's it. Thanks for watching, guys. I hope that this video helped. The build process, if you're building your own M7, or maybe if you're looking or interested in a kit, you can kind of see what goes into building one of these. It's a great airframe. I am planning on doing more of these build videos in the future here, so if you have any comments, suggestions, or questions about this build video or one that you want to see in the future, let me know in the comment section below. Feel free to leave a like and subscribe to the channel if you want to stay up to date with everything that's going on. Thanks, guys.